Welcome to the Queen of Bone 2 assembly instruction video. In this video, we're going to take a Queen of Bone 2 circuit board and we are going to make it into a completed guitar pedal. I will show you the tools that I'm using and some of the techniques that I'm using, which shouldn't differ too much from the regular DIY process. However, the assembly part, especially during the end when we talk about the enclosure and putting the Queen of Bone 2 into an enclosure and such, there's a couple little tricks I'd like to share with you just to make it easier on yourself. For most DIY pedal builders that are experienced, this should be very straightforward. If you're new to DIY pedal building, welcome, and we're about to get started here. So first off, I have the Queen of Bone 2 circuit board, which I have in front of me here. I also have the instructions I printed out on the instruction manual for the Queen of Bone 2, which are in my hand. And most importantly in this instruction sheet and all these papers is going to be the component list, or the bill of materials. And this bill of materials will show us exactly what parts we need and what order to put them in and so forth. So the first thing we're going to do is we're going to separate the daughter board on the bottom from the main circuit board on top. If you can see closely, there's a couple perforated holes to make it easier to snap. You can do this over a corner of a workbench, or if you'd like, you can just snap it with your fingers, putting a little pressure with your thumbs here and pry it apart like so. I'll show you. We go like this, and it'll snap apart. As illustrated in the instruction manual, you'll see that there's a couple little wings that need to be taken off, depending on how yours breaks cleanly or not. And we'll just snap these off with a pair of pliers, like so. And take off this little nub here. There's a couple little nubs left over here, which I don't know I can get too much of. You can use a little bit of sandpaper or a file or some other abrasive. I like using an old file like this. Be careful not to breathe this dust in. It's not good for you whatsoever. It's probably fiberglass. So we're just going to file this clean. Get my tools ready to go. I'll show you the main tools we're going to be using in the assembly part of the video, at least populating the components, will be a pair of needle nose pliers. I have some EREM flush angle cutters here, which are fine. They'll be working with us today. I have a ball of blue tack. Blue tack is a great little trick. It's nice to hold the circuit board while you're working on it. It doesn't leave residue, and I can maneuver it, and it's pretty sturdy. I can stand it up. I can also use it to put components down and hold them in place while I solder. I do have a Panavice here, but I never really use it. The Panavice is nice and all, but you have to keep on clamping it, and for this application, I just find it faster to do blue tack. And then a couple other things. I have a flux pen, which is compatible with the solder that I'm using, which is a no-clean leaded type solder for easy soldering. You'll see me paint a little of this on while I put the components in. I do have a desoldering station, or you can use some solder braid like this in case we make a boo-boo and get two components close together. But as the instructions indicate, we're going to populate starting with all the 1/4 watt resistors. I'll do a few in real time so you can see it, and then we'll just speed up the video so you can see it all, the same thing over and over until we're all done. So let's get started. So I will grab 4 10K resistors and get them started like so. I usually do a little preforming with my hands here, and I will kind of do that, get it set, and I like to repeat that all for all my components that I'm going to do. The component list says to stuff them into R5 and R8. We'll do that once we find them here. R5, R8. Perfect. And R16 and R19. R16 and R19. I have my soldering iron with a pretty fine tip here, and it is running at 750 degrees Fahrenheit. You You shouldn't spend more than, say, about 3 seconds on each pad. You run the danger of melting it. If it's taking longer than about 3 seconds and you're not having much luck, it's probably because your iron's not hot enough, or the parts aren't clean enough, or something like that. So here we go. We got the 4 resistors, the 10K soldered in, and now there's these little ends here. You can see them. We have to clip them off, and I'm just using my flush cutters to clip them off over the trash can. And there we have it. The 4 10K resistors are now installed into the main board here. Okay, the resistors portion is done. We put all the resistors in the board. That should be in the board and also into our little breakout daughter board. We'll just take a quick look on the back side to make sure we didn't miss anything, to ensure that all the leads are soldered in properly. Also to make sure that we didn't bridge any 2 holes together that shouldn't be. It's looking pretty good in this aspect, so we will move on to the next component. And the next component I'd like to do would be the diodes, since they're also very not very tall, just like the resistors. It'll be easier to put them in at this time. So moving along to the diode value, we'll start with the 1N5817s. Okay. The 1N5817s are for the power supply and the polarity protection. So we will bend them up just like we did with the resistors carefully. These have a little bit thicker leads typically than a resistor, and that's all right. So we'll bend these guys down, and these go into D13, 14, and 15. So I see 15. Got to pay special attention to where the gray stripe is, of course. The gray stripe indicates the cathode portion, and we want to line that with a gray stripe on the circuit board as well, which you can see here. So we will do that and pull it in. And the other 2 are 13 and 14, which are over here. And the stripe on these guys is oriented towards the top of the circuit board, so that's good. Now the next diodes are the actual diodes that make the sound in the clipping circuit. So these will be on each bank on the sides here. We have the number 1 bank are on the left side of the board, because as you remember, if this is upside down, the first half of the board on this side the signal will enter, and this is where those diodes are. And then the second bank will be over here, or on side 2 of the board. I like to ensure that all the different sides, whatever diodes you do end up using, are the same. So when we talk about D7 through D12 on this side, we want to make these the same. And over here on this side, we want to use the same type for this bank as well. So with that being said, the original ones, as outlined in the manual, are 1S1588, which are still available. It's a kind of a generic Japanese silicon diode, and you can get those various sources. The other one is an MA856, and that one is pretty hard to get. They've been out of stock for quite some time, and those that do have them charge a lot for them. But you can use just about any type of diode you want. You might want to experiment a little. You could put sockets in here to, to test the different sounds, or maybe you already have a favorite. I'm going to use, on the first side here, we're going to use just generic 1N4148, which are very common and work very well. So let me grab those. These are very small, and again, need to be bent just like all the rest of them. So we're going to take these and bend them appropriately. Just like all diodes, you'll notice, I don't know if you can see in the camera here, but they have a stripe, and that black stripe indicates the cathode again, and we want to make sure we orient that to match the circuit board, which shows us which direction it should go. All 6 are preformed. This is a good time to use your putty. I will get this ready, kind of warm it up a little bit, and I will insert these into, I'm going to put these on the first side actually, so I'll do them over here. And all of the stripes should be facing upwards. So we can see here on the board, all these guys are going to be up like this and so forth. So let's do that. You have to be somewhat careful with these glass diodes, because if you bend them too strongly, they can break the glass and then they become unusable. So just pay attention that you didn't chip the glass or break them while you're inserting them into the board here. And once I got all of them in and I'm sure that the marks are oriented in the right spot, I'm going to try to push them in with my finger, even them out. But this is a really good time to use this poster putty or blue tack. I'll just make sure they're where I want them and use it to smash and hold them all down while I go on the back side and solder them. It's optional, of course, but on any of these connections I could use my flux pen. This Kester flux pen is kind of like a magic marker with flux, and I'll just use this to draw some flux on the circuit board and help me make my connections. Let's go. Quickly inspect my joints just to make sure I didn't short any of them out to each other. They look good to me. I'll take a quick 180 here and do the other side. Okay, I will remove the blue tack off the top, and I notice that my diodes are in nice shape and pretty even where I'd like them. I'm just going to clip the excess leads with my clippers over the trash can. For these ones on this side, I'm going to use a similar diode, which is called the BAS33. Everything's ready to go. The next thing we'll do will be the sockets for the ICs. The sockets are 3 right here. We use sockets because if when you're soldering an IC, you have to be very careful. A socket allows you to swap it easily and also keeps heat off of the chip and make sure it doesn't get damaged. So let me grab those. I got my 3 sockets here on the board, 1, 2, 3. And I'm going to be very careful to make sure that the notch is the same as the notch in the socket. I want to make sure that the orientation is correct. So I'm going to flip over on the back, and just to make life easy, I'll take my flux pen and I'll put some flux down on the pads where the IC should be. And I'll start with the one in the middle of the board, which is for the charge pump, which is IC3. I'll orient this upside down like this. And what I'm going to do is I'm just going to put a little blue tack over the top to hold it in place and make sure it doesn't go anywhere. And then I'll flip it upside down and tack it in with my soldering iron and solder. Okay, all set here, got it in. I can remove my blue tack, and we noticed everything is good. The notch is down, facing down where it should be on this particular one. Now I can do the ones for the IC1 and IC2 on the other sides here. All right, looking at the circuit board here, we see all the pins are soldered. There's no solder bridges between any of the others, so we'll take that and make sure everything looks good and move on to the next step. Here's the switch. We want to make sure that we put it with the on facing towards the top of the board, and we'll do that just like so. The same thing applies. We can put the blue tack on the top or the poster putty here to make sure it doesn't move anywhere while we work on the other side. Very easy. And just like that, we now have a new switch installed. The switch here, of course, the left 2 switches apply to this diode bank, and the right 2 switches apply to this diode bank. And depending, the more switches you put on, the more clipping you'll get in your circuit. So we can experiment with these later, of course. The next step we're going to do will be the presence pods here. These are simply the upper treble frequency content, kind of a set and forget it. If the pedal is too bright, you can, of course, turn these down a little bit. These are both 50K, and I will grab them now and put them in as well. These are kind of Bourne's 3362 or so, and what we'll do is we'll place them in the right orientation here. And again, you can either use you can use a putty, or you can use your finger to hold it while you make sure it's in the right position, flush to the board. In this case, I'm just going to use a little putty. Looking good. Not too bad. Let's put the other one in now. Looks good. Got both in here. Looking nice. We'll take my flush cutters and just trim off these little 3 leads we don't need. All right, now we're ready for the next step. The next step, what we'll do will be the film capacitors and also any ceramic capacitors. I'm going to do the ceramic ones first just because they are the smallest. In this case, there are two 100 picofarads or 100 PF ceramics. I'll grab those. And these 100 PFs go into C12, C3. C3 and C12. So here's C3. Got one. And let's see where C12 is. Over here. All right, both installed. And I will tack them in with my soldering iron. Okay, looking good. They aren't sticking up too high, and I will just cut off the leads. Great. Now we're going to go on to the film capacitors. The first value we'll start with is 100 N or 100 nanofarad, and it looks like we're going to need two of those, so I'll grab two. These are Panasonic ECQ V type. You can use, whatever, WEMAs or EPCOs, or they don't necessarily have to look like this. C6 and C15. There's a C6. I'll take a minute to inspect the board here. It's looking pretty good. On the bottom, I don't see any crazy solder bridges or traces. If we look closely, the leads are clipped pretty well, pretty nice height, and not too close to the board. And we'll continue on with our populating here. And now the last component we need are the electrolytic capacitors. So let's take a look here and see what we need. The biggest one is the 100 UF. And I'm a big fan of using these in the builds here. These are 100 UF 25 volt 8 millimeter in diameter, and they're very short. These are much shorter than the regular ones. You can compare and contrast to a 25 volt one that's 11 and a half. These guys are narrower, but they're also taller, and therefore, it's personal preference, but I like the component's height to be kept down too much of as a minimum. Regardless, we are using 25 volt caps for this build since it does produce voltages around 18 volts with a charge pump. So we'll take that 100 UF cap here, 100 microfarad, and throw it in C1. It's designed so that this guy does have a lot of room, and it's short, so we'll tack this one in here. Also pay attention to the square peg. It takes the longer lead of the capacitor. Great. Now we are looking at doing the rest of the capacitors. Great. Everything's looking great right now. We just need to make sure we put the chips in. So we have the charge pump here, and then we have two of the dual op amps here, and you can use whatever you like. 4558 or TLO72 are fine. So let me go get those, and we'll put those in now. All right, so we have the chips here, and as you can see, the legs are a little bit splayed out, so we can just roll them carefully on the table and make sure that they are straight. This will allow us to put the chips in the sockets without much trouble. Okay, this is a completed Queen of Bone assembly, and we're going to stop here and get our enclosure ready, because the rest of the assembly requires very precise drilling and to make sure that everything else on is lined up appropriately. So double check everything, make sure you're no solder bridges, everything looks clean, all the leads are trimmed properly. There's nothing that looks like it's like touching something else. You didn't miss any components on the top. Everything is 100%, and we'll get ready to drill the enclosure and get this and this all lined up with everything else you need. So stand by. All right, we're back, and we have the drilling template printed out here in front of us. It's very important that this is printed 100% to scale. If it's not, things are not going to line up for you and you'll have a bad time. So what I did is have a little reference square on the bottom, And if we take a look at the reference square, it's supposed to be 1 inch by 1 inch. And got my little measuring calipers here, and we look at this one. And this one only is about 0.9 inches and a little bit, 0.93 or so. So obviously, if we use this one, it wouldn't work so great. So this one's out. Something happened with the printing process, and we don't want to use that one. On this particular template, we check it out, and the square is precisely 1 inch, and the printer printed it out to scale. So this is definitely the one we want to use, and make sure we measure that and double check before we get carried away with everything else. This template itself is a 1590 BB box, or one of these in landscape mode, and will be the center. And what we're going to do is we're going to cut out the outside edge here, and these 4 little corners will be disposed, and we'll fold this in, and we'll show you how to do that. So let's get our scissors and cut it out. Okay, our template is pretty much ready now. We want to be folding it on the lines here and as straight as possible. So try to make this happen and make it as straight as you can. Okay, what we should have now is a little box formation that it's going to fit over the top of our enclosure. Speaking of which, we can get the enclosure out of its wrapper and make it ready to go. Take the screws out and so forth. So with that, I will take my box and I will put the enclosure template on top of it, and it should be a nice fit for everything. I have some painter's tape here, which I will use to tack this in position in a couple spots. And what I will do is I will just put a little on the side here, and another on this side. And what I'm going to take is look at the line that I made on the top and try to make this crease as lined up as possible with the enclosure. I want to see a nice straight line from where the top is all the way across, and I can hold it up to the light if I need to. When I'm happy with that, I will make sure everything's smooth and fold these paper in like so. The line is nice and even, if you can see it there. Take my painter's tape again, a couple pieces, and I will tape the other sides to the enclosure. I should be happy with everything, making sure that the lines and the creases that I've done are centered on the enclosure, and everything is all happy and ready to be drilled. If we follow this and do precise drilling, everything will line up great, I promise you. The magic tool for this procedure is a center punch. This is an older one here, a little rusty but works well. Here's a newer one. This is fine. Basically what happens is when you push down on it, it'll spring back and make a nice indent, and this is perfect for what we want when we're doing precise, accurate drilling. So the one thing we want to talk about and make sure that we don't make a mistake here in this part is that obviously this is the top of the enclosure and this is the bottom. These are the foot switch, the 3 knobs, volume, gain, tone, volume, gain, tone. And then on the top of the enclosure is the DC jack here, and then the in and the out 1/4 inch jacks. We want to make sure that on the LED indicator lights, we only pick 2 locations. So we want to pick either the outside 2 locations or the inside 2, but not both. On this particular build, I'm going to do the inside 2 locations and make sure that I do not mark the outer ones. So this is really easy. We'll punch right through the paper as close to the holes as possible with a spring punch and mark all our locations like that. It'll make a nice satisfying click when you get it in the middle. All right, we'll flip it over and do the top ones, of course.
The DC jack and the other two here, just like so.
All right, now I'm satisfied. I marked all my holes. What I'll do is I'll take this template off and put it aside. Since I use painter's tape, it's relatively easy to get off without leaving a mess, which is what we want. Okay. And if you'd like, this is an optional step, but if it's hard to see these little holes that we just marked, which it may be, I can use a little Sharpie to put a little dab of ink on each hole so that it's easier to see when I'm going to drill them out. You don't have to do this, but it really does help and kind of shows up where the markings are because it's all bare metal right now, of course. Of course, you can do this on a finished enclosure or pre-powder coated one for you. Just be careful that you don't mark the paint. You may want to tape everything off first before you do so. So here we are, ready to be drilled. Everything is marked. The drill bit will be really nice, and we'll go downstairs and put this on the drill press and get ready to make some holes. All right, here we are at the drill press. I have my enclosure all marked that we just did. Well, the holes, I highlighted them with a little bit of magic marker or Sharpie to make it easier to see where I got to drill. And in my drill press is set for the slowest speed with an 1/8 inch bit right here in the middle. 1/8 inch I find is a great starting point to make your initial holes, and we can always make them larger as we get larger. So let's drill these holes out real quick. Okay, our initial holes are now drilled. As we can see here, we got the controls and the 2 LEDs and the foot switches and the top holes here. Now, the best way I find to drill holes like this is to use a step bit. It's a bit that looks something like this, or different sizes like this. And what we're going to do is also keep on hand a little stash of parts so we know exactly what sizes to drill. I have a potentiometer here, which we're using. I have a 3 PDT foot switch. I have a DC jack, just to make sure I get the right size. And then lastly, I have the 1/4 inch jack that I'm using, or 6.3 millimeter that I'm using on the back here. So I'm going to swap the drill bit here for the appropriate size step drill. And we will use the step drill to enlarge these holes to make it work. And let's do it. Okay, now we have our drilled enclosure ready for populating with all our board and everything. We have our board that we finished in the previous step right here, all populated, waiting for the potentiometers. And we'll put these to the side just for a minute. The potentiometers here are the appropriate value. We have B25K, B100K, BA100K, and what we're going to do is we're going to prep them and simply snap off the little tab with a pair of pliers here because we're not going to be using this. So I'll do that for all 6 of these pots. Perfect, all set to go. Now, what we'll do next is going to actually be insert the pots in the right order on the circuit board, but we're not going to solder them in just yet. We'll show you. So in the correct order as they go, the circuit board will be flipped upside down like this, and the tone is B25K, which goes in the middle. The other ones here We have the B100K, which will be the gain, and we'll put those in as so. And lastly, the A100K will be on the upper left here. Make sure you get these correct, that you don't mess them up. It's quite a pain to take one of these out. Now, normally this is going to go inside of the enclosure like this, right? However, since this is a complete mirror image of each other, it's a lot easier to actually just temporarily flip this over and use it as a template. So what I'm going to do is put all the potentiometers lined up in the holes through the back side like so. Now it may take a couple tries and a little delicate balancing here before we get them in, but what we want to make sure is that they're all in, and all the holes are lined up where they're supposed to be. So let's see if we can do this. I'm applying firm pressure from the back here because I don't want these other holes to fall out of the enclosure. So I notice that I have them all lined up nice and neat through here. And what I'm going to do is I'm going to use the nuts. I don't need the washers right now, but just the nuts to kind of tighten up everything inside of the enclosure and make sure that these are going to be snug. Once we're happy with the positioning, we will then solder everything down and it will become an assembly. So just like this, I'll use one of my deep sockets to tighten up all the screws. We don't have to go crazy tight with this, just enough to be firm. All right. Okay, these are all tight, and if I held everything in place right, all of my potentiometers are still going to be nicely stuck through the holes that they're supposed to be. You also want to take this time and make sure that everything is centered as good as possible, and that none of these pots have twisted or anything like that. If they are, you can gently use your pliers or something to kind of move them back and into position. I'm pretty happy with this. The one thing that I do want to check is to make sure that we are pretty much parallel here. You don't want this to be up too much or down too much. These want to be exactly parallel with the enclosure itself. Pretty happy with that. That looks pretty nice to me. I think we'll just double check on the other side here, and it's looking that this circuit board is parallel to the face of the enclosure. With that, I will solder everything in place. A little bit of my flux pen will help ensure a good connection. So we also want to make sure that we are using the insulating covers on each of these. These are not really necessary since they're not touching the back of the circuit board, but the ones that are in the back of the circuit board here are very necessary, because if they're not, the metal back of the potentiometer will short out. We do have these plastic caps that come with it, or you can use another insulating material like tape or foam or something like that. I got my iron warmed up here, and I'm gonna grab a little solder, and we will tack in just a couple of these to make sure that everything is going to be all right. So let's tack in, I'd say the middle one on each side here, and I will just re-inspect everything to make sure that it is 100% still in the position that I want, nice and parallel to the main face. Once that is a go and accomplished, I will use the rest of the lugs and solder everything in. We have our assembly here. This is pretty much solid now. It's not going anywhere. The solder is holding the circuit board to the back of the potentiometers, and it's a nice big assembly. The next step is going to be using the header pins. Long header pins is what I recommend to attach to this board. To get set and ready to do that, I will just flux these up quickly, and I'm going to grab my row of header pins. These are long header pins is what I like to use. They're very inexpensive and they work well. Each one of these is spaced 2.54 millimeters from each other. The actual height of these guys is about, let's see, about almost 0.8 inches, and that would be about 20 millimeters high. So if you're looking for these, what they are. Also, what I would do is we want to make sure that we're putting them in this slot here, so we want to make sure that we have the right number. So I'm going to count off 8, and snap it off. You can snap off with your fingers or your hands. It's not a big deal. But 1, 2, 3, 4, 5, 6, 7, 8. One too many, so I'll just get rid of that. This we're going to tack into this board here first, and we can leave it in this enclosure or you can take it out, whatever is easy. But the most importantly, we want to make sure that there's 8 of them, and we want to make sure that these are up high enough so that we're going to have a good contact with the upper board. So what I'd like to do is just tack them in and making sure that we're level. So let's do that. You can use a little from the top down soldering technique or whatever you're comfortable with. I'm just going to do one for now. And what I'm very interested in is making sure that I get this straight up and down with the board or perpendicular. This one is not, so I'm going to work on that and solder it until it is 90 degrees. That's why I only tacked one in. That is very good. It's about 90 degrees from the other board. I'm very happy with that. I'm looking at the other side to look even. I look at the other side, it looks even as well. Now I'm going to take my time and tack in the rest of them, ensuring that they are still not moving, and it's going to be 90 degrees from the other one. You can attach these from the top, the bottom. It really doesn't matter. The most important thing is to make sure that they don't short out and that you're not attaching 2 adjacent pads to each other, because that will be a problem. If you do mess up like that, grab some desoldering wick and just make sure you clear the gap that's supposed to be there between the 2 adjacent pads. Otherwise, you'll have a short circuit and it won't work. Okay, all set. We have our 90 degree or close to 90 degree pins set up here, and we're ready to take this off and complete assembly. Okay, here we're back, and we're about ready to prep the daughter board for insertion and mating with this guy here. So I have the daughter board that we did in the previous step, and we did solder in our CLR resistors. At this time, I'd like to flip it over and put in the LEDs that we're going to be using. I picked out 2 LEDs here that I'd like to use, and we want to make sure that the longer leg goes into the square hole. So I'll do that and put the longer leg into the square hole. And then what I like to do is take my pliers here and just make a little 90 degree opposite bend on the end here. And this makes sure that the LED is not going to fall out. If you can look there, you can see it's just going to be captive. I'll repeat the same thing for the other side. We're going to take our 3 PDT foot switches here and unscrew the top nut and the 2 washers that come with this particular one. Yours may be a little different, of course, but it'll work just fine. These are solder lug 9-pin with a little holes through them. And what I like to do is, and for this installation, it doesn't really matter what the height is that you set, but you want to make sure they're both the same on each one. For this purposes, I'm going to leave them both stock, but I am going to run the washer, this little lock washer here, that comes with it as an extra security. So what we're going to do is we're going to insert these switches into the daughter board carefully. If you can see here that there's these little holes that are in the side, those holes should be running vertically north to south. So they go like this. You do not want to install it like this. This is wrong. So make sure that you line it up appropriately, and it should match the pattern here with the holes running north to south. Take a look there, just like that. So I'm going to press this on carefully until it kind of gets in there, and the friction itself should hold it in nicely, and it's not going anywhere. We'll repeat with the other side again, oriented like this. Everything's gonna be fine. And now we have 2 switches in our daughter board. I like to run these little lock washers just as an extra security, so I'm going to put those in because that's going to alter the spacing, which is very important when we get everything lined up. So I'll put these on like that, and then I will insert this assembly into here just to line it up and check it out. Everything's cool. So now we're going to take our original assembly here, which we soldered on this 90-degree header pins on the back and the entire assembly, and we'll put it inside. And it should line up because if you drill your holes accurately and we did the mirror thing, everything should go in with very little problems, and it'll fit in just like so. At this point, we can put our nuts down. I'm not going to bother to put the washers just because I'm probably going to be, painting this enclosure and pulling it out and so forth. So we don't really need to put the washers down, but on the final assembly, I certainly will. And we'll put these all together here and tighten these up so that we can make sure the circuit board is very well in its position where it's going to be. Okay, very good. We have our circuit board installed inside here. It is secure. It's looking pretty centered into the enclosure as we wanted to. Because we drilled our holes accurately, everything is lining up, and there's nice room here for our jacks and so forth. We have these header pins coming out, and of course these header pins that are in there, right in the side there, are going to line up with these holes that we have here in the assembly. I again would like to put a little bit of flux on here just to make it easier to solder. It's completely optional. I will put the matching lock washers on here because I want to make sure that they're both the same height overall. So I'll put them on. And this is now going to carefully slide into this assembly and make sure we catch all 8 of those header pins as we do so. So I'm going to line this up. I'm going to line up the 8 header pins, slide it all together, and get these foot switches through the holes that they're designed to be in. Depending on how your header pins are situated, you can move this black plastic piece up or down a little bit. I just left it where it was for now. I can use the circuit board itself to push that down to make sure everything is going to align. You could do that ahead of time, or you can do it now. It doesn't matter. But as long as you're careful, those black plastic piece on the header pin will slide wherever you need it to go. And I'm ensuring everything's lining up here. Nothing's bowed out. The circuit board is nice and flat. It caught all 8 of these header pins down low. My drilling was accurate, so everything lines up where it should be. And I'm going to use the 2 nuts on the outside here to attach the foot switches to the enclosure. Make sure that these are fairly tight because, this is how it's going to be mounted, and we want to make sure that it gets in the proper position. These are all tight. These are pretty tight. The LEDs are still floating right now, but that's okay. We have a last final check here to make sure that our circuit board is both in alignment where it should be here. It's also vertically flat, if we can see it here. If it's not, please adjust it so there's no stress on the circuit board itself and everything's happy. And then once we're done with that, it's time to solder the foot switches in place. Just be sure that everything is where you want it, because once this assembly is soldered, this is the way it likes to be. And if you change the height of anything, it could be a problem down the road. So what we're going to do here is, again, I'll use a little flux because I'd like to have a little help on these connections. You don't have to, but it helps. And what we're going to do is we're going to do an alternating pattern. In order to not damage the switch, we're going to try to use a hot temperature. Again, I'm running about 750 degrees on my iron, and I'm using leaded solder. And what I'm going to do is whatever connection I make on one side, I will make on the other. So I'm going to use this top left one, for example. I'll make this one first, and I'll try to be on here less than 3 seconds, about that. Done. Now I'm going to move over to this one and do the same thing again. And that's about right. Now, because these are all connected in a row, I'm going to go over to the opposite side row on the same switch, we'll call it the upper right, and do this one. And I'll do the same on this switch. This gives it a little time to cool down in between soldering, and you're less likely to have a problem with the switch, of course. Now, because the next row we haven't done is the middle row, I will do the middle row again. And I will touch that one up here, and I'll do the middle row on the other side. And again, we'll just keep alternating back and forth, trying to use a new row, or we can call it a column, I guess, if you wish, to make sure that the heat dissipates effectively. I'm trying to use a hot temperature and not stay on the switch more than, say, about 3 seconds would be wise. All right, we're back, and we got the all 9 on this side and all 9 lugs of this side soldered in, and we did a great job of alternating back and forth in order not to cook the switch and cause any problems. Next, we're going to do the center header pins here, which look pretty lined up. The board looks centered. Make sure everything looks in accordance here, and we were going to touch them off with our soldering iron. We want to be very careful, of course, not to make sure we don't short these pins out just like we were before. If you do make a mistake, you can always use a little bit of desoldering braid in order to kind of help yourself out and correct the problem. Okay, we got all the header pins soldered in properly. There is some excess hanging off here. We can cut that now, or we could wait till the next step. I'll just take care of it to get it out of the way and make sure that we cut the excess of these pins off here. Now that we got this all set, the header pins are soldered appropriately, we're going to now install the LEDs. Remember that we kind of left them hanging here and they're not quite installed. The holes I drilled for these 3mm LEDs is 1/8 inch, so they're going to be a perfect match. What I'm going to use is just a screwdriver like this, and we'll take this screwdriver and kind of poke this LED down into the hole until it's on the right height that we want out the front. I'm going to use this as well, the same on the other side. Since I use flat top LEDs, it makes a nice clean finished look here on the top. You can use whatever kind you want, of course, or if you have bezels and such, but the flat top ones go nice and flush with the enclosure and almost look like they're installed when you get them level. Now that I'm happy that these are level with these flat tops here and they're the right height and all, I will carefully put it upside down, and I will solder the 4 connections for the LEDs. Once we're done with that, we'll just clip off the excess, and that's it. All right, the whole thing is now assembled aside from the DC and the in and out jacks. If we look, we have a 2-tier approach, with this one being higher than the bottom. Everything is level and not out of whack in that aspect. We're both parallel to the face of the enclosure. There's no stress on any of the components. It's a solid thing. If we take all these nuts off and everything, the entire assembly will pull out as one, and we can also put it back as one, which is very nice and very helpful. There's a couple different ways. It's basically, we have the different holes here. We have the in jack and the ground hole on this side. We have ground and 9-volt for the DC jack. And then over here we have ground and out jack. So we need a total of 6 wires and 6 conductors. We could have soldered it in an earlier step, but you can either top solder it now, or you can take it out and solder it, and then we'll put it back in. So let's take a look here and disassemble and just make sure we get that done. Here's our whole assembly. If we're careful, we can put it back in the same way. Be careful if you have any washers in the bottom that you do put them back in so you can maintain the same height and so forth. We also want to double check and make sure there's no loose leads that are in the board, or like right here I messed up and there's a potentiometer lug that was not soldered properly, was missed during assembly, so we want to make sure for things like that. At this point, I'm going to prepare my wire and my leads to wire it up. I'm just using some 24 gauge stranded. Pre-bond stuff that you get from like Small Bear is really nice. Ran out of that, so I'm just using some regular stranded. And I'll use my wire stripper. But basically, I'm going to put in 2 leads on each one of these guys here. On the in jack ground 9-volt, and then ground out jack, and leave about 3 inches or so of lead exposed. So we'll do that now. Okay, we're all set here. Notice I kept approximately 2 to 3 inches of length off each wire. I've routed these just down for ease of routing, and I'm about ready to reinstall this back of the enclosure and make the final connections. So I'll take everything, making sure it's clean, making sure I didn't have any splinters or any shorts in between each one of these connections that I just made. So double check those to make sure you didn't do anything like that. And we're going to put it back into our enclosure. So carefully realign everything back up, paying special attention to the LEDs, also paying special attention that you didn't forget the washers like I almost just did. Put the washers back on if you used any. Go on the bottom here. And we'll put everything back together. I will use my screwdriver and just kind of make sure those LEDs get back into the same spots they were, so everything goes back in. I'll put a couple nuts back on here to hold everything together, and I'll put the couple nuts back on the bottom here. Here's a standard power jack that we have here. This one's just white. There's nothing special about it. You can use one of the inside out ones that attaches with a nut on the outside if you wish. That would make it even easier to disassemble because you don't have to desolder anything. But for now, we'll just use this, and it's not a problem. I will insert it into the proper hole here and tighten it up. Strip the wires and make my connections. All right, now we can just make sure everything's tightened up here, and we're ready to do our initial power on test, and we can ring it out and make sure everything works. Last checks you want to make sure is to make sure you put everything together properly, of course, but most importantly, you put the chips in. That's a pretty rookie mistake not to do that. Everything's wired up. You didn't miss any of these connections. You're not missing any components. Everything looks good. There's no empty pieces of lead or any pieces of metal stuck in the box and so forth. And we'll be ready to test it out briefly. So I'm just going to hook it up to my pedal power supply here, running at 9 volts, and just check for lights, hopefully. I'm going to plug it into my power supply here and see what we got. Oh, a light. That's a good sign. And another light. So we know that the switching scheme works, that the power works. All that's left to do is test it with audio and make sure we're good to go. So that concludes the Queen of Bone assembly help instruction video. I hope you found it somewhat informative about some of the processes and how everything goes together. Most importantly, just taking your time, drilling everything to scale, ensuring that the scale is correct and that you put these in the correct order and in the right way. Using header pins will make your life a lot easier. Thanks for checking out the Queen of Bone, and as always, if you have any additional questions, just leave a comment or send me a message. Thanks.